This video focuses on helping you think about what an equation represents and how to use mathematical reasoning to determine a solution. When writing an equation, the equal sign communicates that two expressions have the same value. For example, we know that both 7 plus 5 and 2 times 6 have values of 12, so we can write 7 plus 5 equals 2 times 6. The equal sign communicates that the expressions have the same value. Sometimes an equal sign relates the values of two varying quantities. For example, let x and y be the values of two varying quantities where y equals x plus 2, which expresses y in terms of x. This statement tells us that x and y change together such that the value of y is always 2 units more than the value of x. Let's visualize this relationship. As the value of x varies, we think about the value of the expression x plus 2. The value of this expression is the same as the value of y. We can freeze the variation at any moment and consider specific values of x and y. For example, if we stop the variation when x equals 4.6, then y has a value of 6.6. Similarly, we can freeze the variation when y equals 13 and consider the corresponding value of x. If y is 2 more than x, and y has a value of 13, then x plus 2 has a value of 13 at this moment. If 13 is 2 more than x, what must be the value of x? X must have a value of 11, so 11 is the value of x when y equals 13, and thus this is the solution to the equation 13 equals x plus 2. Note that when solving the equation 13 equals x plus 2, many people think about subtracting 2 from both sides of the equation to find the solution. The reason for this procedure should be clear from our previous visualization. If 13 is 2 more than x, then x is 2 less than 13, which is 11. Now, let w and r be the values of two varying quantities, where w equals 3 times r, which expresses w in terms of r. Then w and r change together such that the value of w is always 3 times as large as the value of r, or r is always 1/3 times as large as w. Let's visualize this relationship. As the value of r varies, we think about the value of the expression 3 times r, which will always be 3 times as large as the value of r, and this is also the value of w. We can freeze the variation at any moment and consider specific values of w and r. For example, if r equals 13, then w is 3 times as large as 13, or 39. Similarly, we can freeze the variation when w equals some number, such as w equals negative 21, and consider the corresponding value of r. If w equals negative 21, then 3 times r equals negative 21. So the value of r is the number that is 1/3 times as large as negative 21. Therefore, the solution to the equation, negative 21 equals 3r, is negative 7. This is the value of r when w equals negative 21. Some people solve this equation by dividing both sides of the equation by 3 to find the solution. The reason for this procedure should again be clear from our visualization. If negative 21 is 3 times as large as r, then r is 1/3 times as large as negative 21. As the equations become more complicated, the basic reasoning is still the same. Let h equal 1/2 times t plus 4, which expresses h in terms of t. Then the value of h is always 1/2 times as large as 4 more than the value of t. We can visualize how the values of h and t change together. As t varies, we can imagine the value of the expression t plus 4. Its value is always 4 more than the value of t. We can then visualize half of this value, which is the value of h. We can freeze the variation at any moment and consider specific values of h and t. For example, if t equals negative 9, then h is 1/2 times as large as the sum of negative 9 and 4, which is negative 2.5. Let's imagine freezing the variation when h equals 13 and think about the corresponding value of t, which is the solution to the equation 13 equals 1/2 times t plus 4. When solving this equation, it's important to think about t plus 4 as just some number. The equation is then telling us that half of some number is 13, so what must that number be? That number must be 2 times 13, or 26. If this number is 26, then we know that t plus 4 must be 26. We now know that 4 more than t is 26. So what must be the value of t? Hopefully it's easy for you to see that t must have a value of 22. So t equals 22 is the solution to the equation 13 equals 1/2 times t plus 4. This is the value of t when h is 13. Again, there are some common procedures people often employ when solving this equation, and the reason for these procedures can be found in the reasoning we just discussed. As a first step, you could multiply both sides of the equation by 2 to produce the statement 26 equals t plus 4. Multiplying both sides of the equation by 2 is done because we know that half of some number is 13, so the number we are looking for is 2 times as large as 13, or 26. At this point, you can then subtract 4 from both sides of the equation to get the solution t equals 22. The reason for this is that we know that 26 is 4 more than t, so t must be 4 less than 26, or 22. So to summarize, in an equation the equal sign communicates that two expressions have the same value, and solving an equation is made possible by reasoning about these equivalent expressions. Solving equations can be challenging, and requires practice for the reasoning to come naturally. The more you practice, the easier it will become.